Sector area and arc length are really just about portions of circles. In sector area, we're looking at the area of a portion of the circle. In arc length, we're looking for a piece of the circumference, or what I incorrectly call the perimeter sometimes because I think it fits really well. All right, I'm going to use this example, this ACT example, to talk about both. So you've probably learned some formulas for this. If you've learned formulas involving radians, I would encourage you to at least look at this method because the formulas involving radians can get tricky if you're not super comfortable with that under the time constraints and the pressure of the ACT. Not that they're that hard, but you tend to forget some stuff. Okay, so if I want to find the length of this minor arc is just an arc less than 180 degrees. That arc notation, all that stuff is covered in the book. Don't really need to go over it here too much because most of it's self-explanatory. I need to figure out a couple things. One, I need the circumference. So let's do that first. Well, from our last video, circumference is 2 times pi times r. Radius is given as 5. 2 times 5 times r, or 10 pi. Now we can go ahead and look at our answer choices and see that everything is in terms of numbers, not pi. Well, everything's in terms of just regular numbers. There's no pi's in there. So I'm going to go ahead and multiply this out as an approximate of 31.4. By the way, you'll notice that there's an answer choice for that. That's a pretty common trap. It's a halfway answer choice. So the second thing I need is what portion of the circle I'm talking about. Well, a whole circle is 360 degrees, right? 360 degrees. Complete revolution, right? Percent or portion is equal to part over whole. So 60 over 360 is 1/6, right? So now all I got to do is multiply those two things together. So circumference, let's do some erasing here. I think I can remember my numbers. Arc length is equal to circumference times portion times fraction times percent of circle. Okay, so circumference we know is 31.4%. of circle, or fraction of circle in this case is 1/6. So arc is equal to 31.4 divided by 6, which is a little bit over 5, 5.2. Go ahead and put my 0.2 on there. That's it. So what did we do? Found the circumference, multiply that by what fraction of the circle we're talking about. We find that by knowing how big that central angle is that makes the arc. One more time, let's do this with sector area. So where I said arc length was circumference times portion, sector area is equal to circle area times percent of the circle. Very simple stuff. I mean, not always simple to remember or even to do, but the concept, the idea behind it isn't so bad. And of course, sector area is how big this piece of pizza is, right? How big that piece of pizza is. Okay. So let's find the area of the circle. Well, area of the circle is equal to pi, root my r first, pi times radius squared. Remember, we need square units for area. Only way to get square units with a circle is to multiply radius by itself. So that's pi times 5 squared, 25 pi, which is about 78.5. Okay. Got that part done. And we already know the percent of the circle from last time. It's 60 over 360, or 1/6. So 78.5 divided by 6 will be, let's use an equal sign. It'll be 113.8, something like that. Just did that in my head, so it could be a little off, a little loose. But that's how you'd find the area of this sector. So again, it's portion times whatever you're looking for. Whether if it's arc length, it's going to be circumference. If it's sector area, it's going to be area. Keep it simple. Keep it with what works. Recognize the context, and you'll do just fine on these. Check out the last video on circle equations, because that's the stuff that devils people the most. I'll give you a hint right off the bat. The circle equation is really just the Pythagorean theorem.